Hello, my name is Brianna Reed. I have had the pleasure of researching the damaging effects of the non-native salt-cedar plants on the Middle Rio Grande Valley, and more specifically, their effect on the native cottonwood and willow trees in the bosque. This is my proposal on how to reclaim the Rio. Salt-cedar plants are damaging to the surrounding plant life, wildlife, and human life, as they affect the land and water that all species depend on. They are a plant species with a high water consumption, as they require up to 200 gallons of water a day when they are fully grown. To put this into perspective, a fully grown cottonwood tree that stands at a maximum of 45 meters tall requires the same amount of water as the salt cedar that only reaches a maximum of 6 meters. This amount of water consumption affects the surrounding plants as the roots underground battle for water, and the salt cedar usually emerges victorious, with its complex and wide root system below ground. Their root system spreads wide and quickly as it reaches around and between the established roots of neighboring plants. Not only is this non-native species wide underground, but above ground, as it forms dense thickets that can survive under many taller trees, as the cottonwoods and willows. They grow fast and populate even faster, as they have a long seeding time that lasts nearly 3 times as long as that of the cottonwood trees. Their extensive growth has formed compact tree lines that have straightened the river, as the water flow does not penetrate the line with enough force to carve into the land past these plants. The salt cedar also gets its name as it affects the salinity of the water. As the water of the river moves south toward the Gulf of Mexico, it picks up a substance called sediment. This can have a high salinity, which the salt cedar plants can withstand, but many other plants cannot. This causes an overall higher salt content in the river, as the sediment no longer makes its way to the Gulf, but gets trapped by the salt cedar's dense line. Finally, in addition to this high salinity the plants and aquatic life cannot withstand, these trees offer limited benefit to the wildlife, as only 4 species of animals are able to make their homes in the plant. This is dramatically less than the 154 species that are housed in the cottonwoods alone. From 1995 to 2006, scientists with the U.S. Department of Agriculture had discovered a beetle that could help control the salt cedar population. Throughout this time, the salt cedar leaf beetle was released into the ecosystem. In addition to the beetle, there were other efforts made to remove the species by the introduction of herbicides and the mechanical removal and burning of plants. Scientists found these efforts to be up to 90% effective in the permanent removal of the plant. So why did they stop? In 2006, beetles were introduced in Utah to control the salt cedar's growth, and 2 years later they had made their way into Arizona. The beetles had begun to destroy the habitat of the southwestern willow flycatcher. This caused a lawsuit by the Center of Biological Diversity and the Maricopa Audubon Society against the U.S. Department of Agriculture. The lawsuit was settled quickly as the beetles were no longer allowed in the habitat. There are, however, some things you should know about this bird. They originally nested in the native willow trees found throughout the Southwest, and as the salt cedars began to invade, the willows died off, and the birds were forced to find refuge in what they could. They are now protected by the Endangered Species Act and have been since the U.S. Fish and Wildlife Service listed them as endangered in 1995, shortly after the research on the salt cedar leaf beetle had begun. A few of the larger groups and acts that I have taken into account before proceeding with this issue are the National Environmental Policy Act, the Endangered Species Act, the U.S. Department of Agriculture, Animal and Plant Health Inspection Service, Technical Advisory Group on Biological Control of Weeds, and the Salt Cedar Biological Control Consortium. After researching, I have engineered a 3-phase process to control this species in the Middle Rio Grande Valley. By the end of the project, the Middle Rio Grande Valley, from the connection of the Jemez Canyon Reservoir and the Rio Grande, all the way to Belen, just before the Rio communities, will have over 90% control of the salt-cedar population. The first phase will include the northern 10 miles of the river, from the Jemez Canyon Reservoir connection to the pueblo of Sandia Village, shown here. The second will progress south, including another 15 miles from the pueblo of Sandia Village to the connection of the Tijeras Arroyo to the Rio Grande. Finally, the last phase will include the longest portion, measuring 22 miles, from the Tijeras Arroyo connection to the beginning of the Rio communities in Belen. Included in each phase, there will be 5 steps to ensure maximum control while still accommodating the native life. Step 1 includes the mechanical removal of the salt cedars. The mechanical removal will control the upper portions of the plants. In this step, workers will cut off the tops of each salt cedar and will dispose of the plants in a mulcher. This will require a chainsaw, a mulcher, and trained workers to operate the machinery. Step 2 will involve the chemical treatment of the remaining plant. Workers will need to fully cover the remaining stump of the plant in herbicide so that the root system is killed. This step will require a herbicide known for the treatment of salt cedars called imazapyr at 1% concentration. It will also require workers to apply the chemical to the salt cedars. Step 3 will be the most difficult of the steps, as it will require removing the extensive root systems of the salt cedars. The roots will be easier to excavate due to the herbicide, but they still need to be removed. Using an excavator and a mulcher, workers will dig up the root systems and feed them through the mulcher. This will dramatically reduce the repopulation of the species. Step 3 will require an excavator, a mulcher, and trained workers. Step 4 involves the reintroduction of the native species. In this, seeds and cuttings of the native cottonwood and willow trees will be planted in the areas where the salt cedar had previously invaded. This step will be more time-inclusive than the previous step, and it will require the seeds and cuttings, basic gardening tools, and workers. This step is purely a time and maintenance step. It will include the monitoring of seeds planted and the mechanical removal of any salt cedars remaining. The time for this step is 5 years, as that is the time required for cottonwoods to reach maturity. This is also a time for the southwestern willow flycatchers to again nest in the growing willow trees. Allowing this time between each phase will maintain the survival of the birds and will give them time to adapt back to their original nesting trees. A final step will take place after each of the previous 5 is completed for the 3 phases. Step 6 involves the introduction of the salt cedar leaf beetle into the Middle Rio Grande Valley. This will control any salt cedars missed in the previous steps, and the beetle will eventually die out or migrate when there is no longer a sufficient supply of salt cedars. The reason this method had to be stopped previously is due to the southwestern willow flycatchers. However, after the 15+ years they will have to nest in the native willow trees, the final removal of the salt cedars will not be a problem for the endangered species. This step will again require a few years to see true results, but after all steps have been completed, I expect over 90% control of the salt cedar population in the Middle Rio Grande Valley. The budget for this project will include $500 per acre of mechanical removal, $300 per acre of herbicide treatment, $5,110 per month for an excavator, $3,700 to buy the mulcher, 32 cents for every 1,000 cotton seeds, $9.95 for every 12 willow tree cuttings, and $8.75 per hour of work for the workers. With all expenses accounted for, I expect this project from start to finish will cost approximately $24.1 million. The cost for this project may seem high, but in comparison to the billion-dollar road, infrastructure, and maintenance projects that take place in the city of Albuquerque, the $24 million needed is a worthwhile and needed expense. The time for this project is extensive as well. However, accounting for the endangered birds, the maturation of cottonwoods, and the manual labor needed for the eradication of this harmful species, I believe it is a cost we should be willing to take. The final major cost for this project is that it will need to take place during the prime seeding period for the cottonwood and willow trees, which happens to also be the prime time for outdoor activities. As the bosque is a major attraction for the wildlife centers and the biking and hiking trails along the bosque, there may be time where sections of the trail will need to be closed. In addition to the restoration of native life here in Albuquerque, the long-term benefit for this project also includes a restoration of the valuable water in this desert climate. The removal of salt cedars will restore the river to its former glory, as it will reduce the chemical salinity of the water and allow for a stronger flow. This impacts the agriculture in the valley, the city dwellers, and the underground aquifer, as more water will be retained when the water-greedy salt cedars are removed. In conclusion, the one-time cost for this 15-year-long project will indeed be high, but it is greatly outweighed by the benefit of the agriculture, river, wildlife, and citizens in the Middle Rio Grande Valley and central New Mexico as a whole. Thank you for your time and consideration in this effort to reclaim the Rio.